Okay, today we are doing scientific notation. Take a minute and write this down. All right, so when the purpose of the lesson is so that when we have really big, we use scientific notation when we have to multiply really big numbers or really small numbers. Big numbers would be like distance from here to the moon, inches, feet, even miles, or some very small numbers like the size of the measurement of a molecule or an atom. This is when we would use scientific notation. Notation means to write. Okay? So scientific notation is where A is a number between 1 and 10. It can be 1. It can be 1 or greater, but it has to be less than 10. It cannot equal 10. Got it? It can be 1 through 10, but less than 10. And it can't be less than 1. So that number, and it's always multiplied by a power of 10. The other thing is that B, the exponent, always has to be an integer. Negative, positive, whole number. If it's in scientific notation, it has to be negative or positive whole number. Okay? Could be 0, could be -1, -2. Okay? An integer. All right. So when we have just a regular number, a really big number, where is the decimal naturally? Where's the decimal naturally? Let's go with Bryce.
The decimal is naturally in 10.
Where is it on my number 3,780,000,000? Oh, 3,780,000,000.
3.
Where is a decimal naturally in this number?
Oh.
Where does it start? It's not written right now, Ashley.
After the last 0.
Right. All the way to the right at the 0. Okay? So that's where it naturally is. We don't always write it, but it's there. Okay? So to put it into scientific notation, we have to, you were giving me scientific notation, not answering my question. To put it into scientific notation, we have to turn this number into a number between 1 and 10. Where would that decimal be placed? Okay, Bryce.
After the 3.
Between?
The 3 and the 7.
Between the 3 and the 7. So that means it's going to have to jump 3, 6, 9, 10, 12. 12 times. Okay? So if it jumps 12 times, that decimal, we don't count the commas. We only count the decimal digits. The digits. Then now we have a number between 1 and 10, which is 3 and 78 hundredths. And it's multiplied by a power of 10. If we did 12 jumps, it's to the 12th power. Now notice, we started out with a whole number. So my exponent will be a whole number. Okay? We started out with a positive, doesn't matter if it's positive or negative. It's a whole number. So my exponent is a whole number. It's positive. Okay? Now, look at the next one. It's a decimal. Decimals are the same as fractions. So what kind of numbers, what kind of exponents show us fractions?
Negative.
Negative exponents show us fractions. So we know that when we multiply by that power of 10, it's going to have to be with a negative exponent in order to really represent this decimal. So where does the decimal need to move to, Rami?
It needs to move to 6. Or like between the 6 and the 4.
Between the 6 and the 4. So that's how many jumps?
It's 6 jumps.
1, 2, 3, 4, 5, 6, 7. Okay? So it's jumped 7 times. And what would that look like in the scientific notation?
It would be a negative 6.4.
Why negative? It's not negative.
6.4 times
6 and 4 tenths?
6 and 4 times 10 to the negative 7.
10 to the negative 7th power. Okay? The number isn't negative, it's the exponent. In order for it to be a decimal, it has to have a negative exponent. Yes?
Do we have to write the X in times?
Yeah.
Okay.
Or you can do a dot. You can do a big dot. Huh?
I did this last week.
Yeah. Okay, questions? All right. I'd like you to do 2 of these on your own. Okay, this one and this one. Go. Pause the recording. Try it on your own. Okay, so where does a decimal naturally start out on the 620 billion? How about Dakota?
After the last 0.
To the right after the last 0. And how many times am I jumping?
11 times.
4, 5, 6. Good. Sorry, that's supposed to go there, but my pen's working funny. And what does it work out to be?
6 2 10
6 and. We read the decimal as and, 2 tenths.
times 10 to the 11th power.
Good. Okay, the next one, Aton.
So the 0 is supposed to be, it is in front of, it's between the first and the...
Okay, where am I moving it to? We see the
We
decimal.
move it past the 4,
Okay, how many times?
6 times.
Okay, and so what does it end up being?
It ends up being 4 times 10 to the negative 6 power.
Negative 6 power. Starts out as a decimal, shown here as a fractional amount. Okay. All right, so somebody asked, do we write how many jumps? That's fine. If you show it to me, we're writing question, answer. You can either do that, you can say the jumps. Either way, whatever you want to do. You don't have to do both. At least some little squiggles, yes. Okay, so can I continue on this? We understand this part? So what we're doing is we are given standard notation. Seeing numbers like we're used to seeing it, that's called standard notation. Notation means writing. Okay, now we're going to go from scientific notation to standard notation. Okay, so if I start with standard notation, I'm going to start with the number first, 3 and 6 tenths. Now notice, is this going to be a whole number answer or is it going to be a decimal?
Whole number.
Whole. So that means I have to move in what direction? Right. To the right, and I'm moving 5 times. Once, twice, 3 times, 4 times, 5 times. Add the decimal. In all those places, I have zeros, so I end up with 360,000. Please make sure and write your commas. Okay? If I have a negative exponent, I'm starting with 8 and 43/100ths. Which way am I going to move? What kind of number should this end up being? Julio, what kind of number should it end up being?
It should be 0 point and then the number.
So it should be a decimal number. Yeah. Okay, so which direction am I going to go?
To the left.
To the left, and how many times am I moving?
7.
Once, twice, 3 times, 4 times, 5 times, 6, 7. Whoa. I'm adding all those extra zeros. Do I add zeros? Let me give you. Do I add 7 zeros?
No.
No. And I always, with a decimal, you should always be starting it with a leading 0. You move the decimal 7 places, but you still need that lead 0. Yes, Carter.
Tonight on the homework, are we gonna need to show that like squiggly line?
Okay, I just answered that twice. You're gonna have to ask your friends. Okay, so does everybody understand that? Yes? Okay, can we move on, or do you think you want to practice this a bit? Okay, if you want to practice, pause the recording. Here are the answers. Now check your work. Now check. All right, So, in addition to just doing scientific notation, we can also compute in scientific notation. When we're doing this is where we take each number, okay, the numbers are going to get multiplied together, and then the common bases get multiplied together. We're going to rewrite it, okay? So really, isn't this all straight multiplication anyways? Right? I'm just going to rearrange it. 2 1/10 times 1 5/10 times 10 to the 6th times 10 to the 8th. Okay? 10 to the 8th times 10 to the 6th. Now, when I do that, I'm multiplying out 2 1/10 times 1 5/10, and that makes, you can use a calculator for that part. Calculator, sorry about that. I'm using the wrong Apple pen. 3 1/1500, I believe it comes out to. 3 1/1500. And then what am I doing with my exponents? Times 10 to the 8th plus the 6. So it's 3 1/1500 times 10 to the 14th power. All right? Now, the biggest issue here is when they say multiply in scientific notation, you need to finish in scientific notation. And many times, this number is not in scientific notation. Okay, so let's take a look at some problems where we'll see that. Right away, I'm noticing 5 6300 times 3 4/10. I know 5 times 3 is 15, so right there I know it's no longer in scientific notation. Okay, so I'm going to multiply those two together. I'm multiplying those two together, and I get 19. Oops, didn't mean to do that. Okay, 19, and I'm going to do 10 to the, I guess I can do this here. I'm going to do 10 to the 7th times the 8th. And so this multiplies out to 19 and 142 thousandths times 10 to the what power, guys? 15th. Is this scientific notation?
No.
Why?
Because it's 19 and that's more than 10.
It's not a number between 1 and 10. It's greater than 10.
1.9.
So we are going to have to make that number smaller or bigger? Smaller. So I have to keep this expression in balance. If 19 is going to get smaller, then my power of 10 has to get bigger. So how many times am I moving the decimal to make it smaller? Do I move it to the right or to the left to make it smaller? Okay, so the thing to think about is I need to make this smaller. 19 is going to go from 19 to 1 and 9,142 ten thousandths. Right? And if that gets smaller, then the other exponent's getting bigger. Okay? Now I'm in scientific notation. Many times people are getting this wrong because they stop here. Do you understand? That is the common mistake. You have to be in scientific notation. It has to be a number between 1 and 10. Now let's look at a couple of others. Is this scientific notation?
Yes.
Would I stop or would I continue? Yes, stop. Number 2, is this scientific notation? So raise your hand if you can tell me what I would do. Carter?
You need to move the decimal 1 time to the left.
Okay, and so it becomes 1.
1.176.
And does the 10 to the 16th get smaller or bigger?
You turn it into 10 to the 17th.
10 to the 17th. So if this gets smaller, okay, let's look at the next one. Okay? Is this number going to get smaller or bigger?
Smaller.
I have to move the decimal so that it gets smaller to 8 and 342 thousandths. So what's going to happen to 10 to the negative 11th power?
10 to the negative 10.
Right, that has to get bigger, but remember, bigger is the negative 10th power. Is everybody clear on that? Okay, if we are dividing, we do the same thing. Number with number, like base with like base. Okay, 9.1, 9 and 1/10 divided by 3 and 5/10. 10 to the 12th divided by 10 to the 7th. 9. Okay, so then I end up, instead of dividing exponents, what are we doing?
Cross.
Subtracting.
Okay, when we multiply like bases, we add the exponents. When we divide like bases, we subtract the exponents. Okay, so I end up with, and this ends up being 2 and 6/10 times 10 to the 5th.
So
Yes.
so you just divide the whole number.
Yeah, you just divide the decimals
Yeah.
and divide the common bases together. Well, we're really subtracting their exponents. Okay? Any questions? Yes.
So this you turn into scientific notation?
Is this in scientific notation?
Yeah.
Yeah.
But
Yeah.
I thought, oh no. I thought you meant like with the zeros and stuff.
No, this is scientific notation when it's multiplied by a power of 10. The other one is called standard notation. This is, oh wait, here we're multiplying in scientific notation, but when you multiply it all out and add your zeros in, then that's standard notation. Is that the question you're asking me? Yes, Carter.
This doesn't really relate to the problem previously, but like if it's a number, say it's like no number.
Okay, one last thing.
It was like 0.5.
Yes, if it's a decimal times 10 to the 12th, does that number have to get bigger or smaller?
Smaller.
Bigger.
Bigger to make it scientific notation. And so I'd move it once and it becomes 5. And so if this got bigger, right, then this has to get smaller. Does that make sense? All right, I believe that's it for our
That's it.
lesson.
So if that's in the numerator, 0.5, you have to make
We got this in the bag. I'm gonna finish today, and I'm not gonna do a single